at synthesis of alcohol. How can we synthesize alcohol? How can we produce them? How can, either in the lab or wherever, how can we synthesize them? Okay, so let's quickly look at how we can synthesize alcohol. If you're asked in exams, how can you synthesize alcohol? Now, remember that we did oxidation of alcohol to give you aldehyde. Oxidation of primary alcohol gives you aldehyde, right? Secondary alcohol gives you a ketone. So if you want to get back the alcohol from the aldehyde and ketone, what we simply need to do is to what? Undergo reduction, opposite, because you know that oxidation, the opposite of oxidation is what? Reduction. So if I undergo reduction of ketone and aldehyde, definitely I will get back the primary and the secondary alcohol. Okay, so let's quickly look at number one, synthesis, reduction of ketone, aldehyde, and an aldehyde, ketone of reduction of ketone and aldehyde using lithium aluminum hydride. Lithium aluminum hydride, okay? This is called lithium aluminum hydride, or you can call it lithium tetrahydroaluminate 3, okay? And diethyl ether. So reduction of lithium aluminum hydride in diethyl ether, reduction of ketone and aldehyde using lithium aluminum hydride in diethyl ether will give you an alcohol, depending on the class you are looking for. For example, if I have, let's say, this is an aldehyde. Remember, this is an aldehyde. Is that also? So when you have this aldehyde and you are using lithium aluminum hydride in diethyl ether, okay, in diethyl ether, this is a reduction reaction. So you are going to add back the hydrogen that you removed, you have to replace it back. So when you do that, you are going to add one hydrogen here, add one hydrogen here, one hydrogen here, you remove this pi bond, so you're going to have RCOH, add one hydrogen here, add another one here, okay, then this is the one that it has, this one, it has this one already. So I added two hydrogens, okay? So this reaction leads to the addition of what? Hydrogen. One to the oxygen, one to the carbon, then you clean the pi bond. So this will give you a 1 degree alcohol, okay? So this oxidation will give you, this reduction will give you a 1 degree alcohol. So aldehydes will give you a 1 degree alcohol. So the next one is ketone. Ketone is RC double bond O, you have H, okay? So when you undergo this reduction using the same lithium aluminum hydride in your diethyl ether, CH3, CH2O, CH2, CH3, okay? So when you undergo this reduction, the same thing will happen. Addition of hydrogen will happen on both sides. So you're going to have RCOH, RH. So this is also a 2 degree alcohol, okay? So this preparation, we can use ketone and aldehyde. We can use ketone and aldehyde to generate a primary and a secondary alcohol, okay? We can also use formaldehyde. Formaldehyde does not really, this one will give you an alcohol that has no specific class. For example, using the same lithium hydride in diethyl ether, okay? So you simply add hydrogen here, so you're going to have methanol. So this one will give you methanol. Remember that methanol does not have any particular class. It's not primary, it's not secondary, okay? So reduction using this reducing agents will give you this alcohol, okay? So let's use an example. Let's say we have acetaldehyde. If you have acetaldehyde, which is this is an aldehyde, undergoing this reaction with lithium aluminum hydride in diethyl ether, okay? So this is going to be addition of oxygen, because remember that what you are seeing here is actually like this. It's like this, okay? So when you add hydrogen here, you have CH3, CH2OH. So this will give us ethanol. If you have a ketone, let's say we have a ketone, let's say acetone. This is acetone. Let's say we have acetone. And we are undergoing reaction with lithium aluminum hydride in ethoxyethane. Remember that ethoxyethane is the same thing as diethyl ether. So this will give you, add hydrogen to both sides. You have CH3, CHOH, CH3. So this will give us propan 2O, which is a secondary alcohol. Okay, so this reaction leads to the formation of a primary, secondary, and methanol from what? Using aldehydes and what? And ketone. So this reaction can lead to the synthesis of a primary, secondary alcohol. So the number two synthesis, the first synthesis I talked about can only be used to synthesize primary alcohol, secondary alcohol, and then methanol. Okay, now if we want to synthesize primary alcohol, secondary alcohol, and a tertiary alcohol, we are going to carry out a reaction between aldehyde and ketone with Grignard reagent, followed by what? Hydrolysis. Okay, so the next synthesis, number two, I'll talk about is reaction of aldehyde or alkanol, ketone or alkanone with Grignard reagents. Okay, followed by hydrolysis. Okay, so this reaction is very simple. It's a two-step reaction. It is a two-step reaction. So what happens first is that, let's use an example. Let me use an example. Remember, aldehydes. In the aldehyde functional group, remember that this is an aldehyde, the first member of the aldehyde. Also, aldehydes can also be represented as R, C double bond. So the first member of the aldehyde, which is methanol, if you react it with a Grignard, first of all, before we talk about Grignard, I hope you know that when we say Grignard, a Grignard reagent can be represented as what? RMGX. Okay, where R is the alkyl group, magnesium, and the halide. So examples of Grignard reagent, this can be CH3, CH2, MgCl. This is a Grignard reagent. So this is called ethyl magnesium chloride. Another example of a Grignard reagent is CH3, MgBr. This is methyl magnesium bromide. So this is a Grignard reagent. So when you react a Grignard reagent with an aldehyde and ketone, the next step will now be to hydrolyze it to get your what? Alcohols. Now, how can we get primary, secondary, and tertiary alcohol? By reacting these aldehydes with Grignard, then by hydrolysis. Let me show you. For example, let's use an aldehyde. Aldehydes are R, C, double bond O, single bond H. If you treat this aldehyde with a Grignard reagent, let's use RMGX as a case study. Okay, when you react this with this, what happens is that the R attacks the carbon, the MgX attacks the OH. So we're going to have R. For the sake of clarity, let me put prime here, okay, to differentiate it. So R connected to this MgX will go to this O. So it's going to be OMgX. We still have our H here. Then the R from this guy, which is R prime. Okay? So the next reaction will be hydrolysis. That is reaction with water. So when it reacts with water, water will split into H and OH, right? So the OH will go and react with this guy. The the H will replace this guy. So we're going to have R connected to OH. How is it OH? This MgX will leave and react with this. So H will replace. Okay? So we have this and this. Plus Mg bracket OH bracket what? X. Where is the OH coming from? The OH is coming from what? From this side. Okay? MgX will react to this to give us this. So this class of alcohol here is a 2-degree alcohol. So aldehyde will give us a 2-degree alcohol. But inside the aldehyde, the first member of the aldehyde being formaldehyde, the first member of the aldehyde does not have an alkyl group. So that first member of the aldehyde will give you a primary alcohol instead of a secondary alcohol, just like other aldehyde. So when you have the first member of the aldehyde, which is this is called formaldehyde, okay? Or you can call it methanol. When methanol undergoes this same process, it will give you a primary alcohol rather than a secondary alcohol. But the remaining member of the aldehyde groups from number 2 down will always give you a primary alcohol. So how will this one give us a primary alcohol? Watch. So the next thing will happen, react with a Grignard. Let's say we have RMgX prime. Okay? When you treat with this, you have H connected to OMgX. You have the R connecting here. So that when you further hydrolyze with H2O, you will end up having H, OH, R prime, and H. Plus what? MgOHX. Okay? So now this is how you get from aldehyde. From aldehyde, you get your primary alcohol, which is your secondary alcohol, sorry. Then from this formaldehyde, this guy is the first member of this group. It doesn't give a secondary alcohol, it gives a primary alcohol. Why is it primary? I hope you know why. Because of the R. Now, how can a ketone give us a tertiary alcohol? Remember, aldehyde with Grignard hydrolysis, aldehyde with Grignard and hydrolysis will produce a 1-degree alcohol and a 2-degree alcohol. But ketone and Grignard and hydrolysis will produce a 3-degree alcohol. So how can we get a tertiary alcohol from ketone? Watch. Now, what is the symbol of ketone? Ketone is R, C, double bond O, single bond R. So let's differentiate these two R by pressing prime here. Then let's react it with what? A Grignard, RMgX. Let's put prime here for this guy. The solvent for this guy, the solvent that we use to dissolve these guys are diethyl ether. Okay? The same thing here. You can also write diethyl ether. The same thing here, the same thing. Diethyl ether. Okay? So from this reaction, what happens? What you know will happen will happen. That is, the R will go to this side, the MgX goes here. So we're going to have RCOMgX. Where you have your R prime here, Then this second, the R prime, this another R from the Grignard will come and attack from here. Okay? So what next? You hydrolyze. Hydrolyze means water will come in, right? So water will split. Remember, H and OH. So the H will displace MgX and form OH with O. So we're gonna have RCOH. Remember, we still have prime here. I'll have R prime plus Mg bracket OH bracket X. So from this reaction, you will see that reacting this with Grignard gives you this. This is not the final answer. Then hydrolyzing it with water, you get a tertiary alcohol. So this is a 3-degree alcohol. So you can see that from this reaction, we can synthesize a 3-degree alcohol using a ketone reacting with a Grignard. Okay? don't be confused with this prime, these numbers I'm putting here. It's just to differentiate that these alkyl groups are not the same. Okay, this could be methyl, this could be ethyl, this could be propyl. It could be any alkyl group. What matters is you understood what is happening here. So this is the mechanism or the pathway that leads to the formation of a primary alcohol, secondary alcohol, and tertiary alcohol using aldehyde ketone with Grignard followed by what? Hydrolysis. So with this, you can understand that you can actually synthesize alcohol using any of these reaction you are seeing. The first one or the second one can give you any class.